Chapter 4 is all about complex numbers. So in 4.1, we start reviewing complex numbers, which you first saw back whenever you took Algebra 2. So first, let's just kind of go over what imaginary numbers are. First, we have our imaginary unit. Our imaginary unit is whenever we take the square root of a -1. When we take a square root of -1, we always show that as our I. So I typically write my I's like this or like this, making sure that you can tell the difference between an I and a 1, a cursive I and a 1. Now, when we're talking about complex numbers, our standard form is in like this, meaning when we write our standard form, we have our real number first and then our imaginary number second. When you write the imaginary number, it can be a composition of a real number. So let's say something like this, 5 plus 7i, that's an imaginary number. That's what we call imaginary numbers. If we have a pure imaginary number, that's when we don't have any real numbers at all. The difference between imaginary number and pure imaginary is if we have a real number associated with it. When we add and subtract complex numbers, it's kind of the same thinking process as if we just had a variable, as if I was just like x and we're back to pre-algebra. So we can combine our like terms. If there's a subtraction, though, you have to remember to distribute your negative. So right now I want you to pause the video and try to do these 4 problems, acting as if the I value is like an x. So remember how you need to do that back in pre-algebra times. So combining our real unit and our imaginary unit, for all of these imaginary units cancel. Here I distribute my negative, changing the signs of these. So when I combine my like terms, and here once I distribute, I get 0. So when I'm talking about imaginary units, again, this right here is like a -1 when it's equal to I. So if I get into I squared, when I actually break down what I squared is equal to, that's saying the square root of -1 squared. So when you look at the square root of -1 squared, these two components cancel each other out. So when I have an I squared, that is always going to be equal to -1. When I square an imaginary unit, that gets that to be -1. So let's say if I had I cubed, well, I could break that down to I times I squared. And just like this, that is telling me that I times -1. So if I had I cubed, that's a negative I. Let's say if I had I to the 4th. If I had I to the 4th, that's like I squared times I squared, which would be -1 times -1, which is 1. And this component keeps on repeating then. So if I have an I raised to an even number, I'm going to end up with a real number. If it's divisible by 2 and only 2, if it's divisible by 4, that means that would reduce to 1. If it's not divisible by 4 and it's even, that means that would reduce to -1. If I had an odd exponent, that's raised to I, and it's divisible by 3, that means it would simplify to -I. So looking at this now, when I'm multiplying, I distribute in. So like in this case, I don't have any i's, but I distribute that 4 and I get -8 plus 12i. And that right there is my final answer. Here I'd have to FOIL. First, outside, inside, last. So I take my first, I get 8. My outside, I get 6i. My inside, I get -4i. And my last, negative times a positive is negative, and this becomes 3i squared. So now these two become like terms. I can replace this. Now, depending on how you do this, I can replace this with a -1. I squared is equal to -1. So now what I really have here is 8 plus 2i plus 3, because -3 times -1 is a positive 3. And when I combine those two together, I get 11 plus 2i. So right now I want you to pause the video and try to do D and C by yourself, noticing that when you have something squared, you do not just bring that in. You have to times it by itself. So you are still going to have to FOIL this one. The first one you should get 13, and the second one you should get 5 plus 12i. Now, this should have been something that you are used to seeing because we've talked about conjugates. You've talked about conjugates. When these two numbers are the same, but in between these two numbers are opposite of each other, that means these two will always cancel. My outside, inside will always cancel. So when I'm multiplying by my conjugates, first you have to know what a conjugate is. So my real part still goes out in front, so this is still going to be 1. And then my imaginary part still goes second, but if this says adding, this says subtracting. And when I do my FOIL method, first outside, inside, last, I would get 1 minus I plus I minus I squared. When this happens, these two will always cancel out if you pick the correct conjugate. This becomes a plus 1 because this is negative times a negative 1, which is a plus 1. I still have this 1 right here. When you multiply the conjugate, the imaginary unit is canceled out, leaving with just the real unit. Right now, I want you to try to do B by yourself. So you should have gotten 25. Now let's talk about what if we're going to actually write a quotient, so a division with standard form. First, we have to get rid of this divide by. We want to make this into a real fraction. So we have to multiply the top and bottom by the conjugate. So it's only the bottom of the fraction. We want to get rid of this radical in the bottom of the fraction. So the conjugate here would be 4 plus 2i. So we do that on both top and bottom. So if we FOIL the top, we FOIL the bottom. A lot of times people cross these out. These are not crossed out. These are not opposite. On the bottom one is the conjugate. They are opposite. These two combine to get that 69. I squared simplifies to get me my negative 1. So this becomes a negative 6. And this right here becomes a positive 4. Now if I keep on simplifying this then, this now combine on top to get a 2 plus 16i over 20. I'm asking you to write it in standard form though. If I'm write this in standard form, both of these are divisible by 20. And then you should simplify the fraction if you can. In this case, we can simplify that fraction to be 1 over 10 plus, in this case, both of these are divisible by 4. So 4i over 5. And that right there would be my final answer. So when I'm writing my complex numbers, we can take out an I here out of my square root 3 times I can take out an I out of my square root of 12. Because we are smart individuals and we know that we can multiply these radicals together, and I times I is going to give me I squared. Square root 3 times square root 12 will give me the square root of 36. Well, the square root of 36 is 6, and the square root, or I squared, is equal to a negative 1. So that can be simplified just like this. If not, now I have to factor tree these two out. Now, because it's negative, my answer is going to be negative. You could either factor tree this. Now, looking at my factor tree, looking for pairs of 2. So 2 times 2, because there's 1, 2 here, 1, 2 here, that becomes a 4. And because this is negative, this is I. And I still have the square root 3 here. You could also do it by perfect squares. So I'm going to write this subtraction. That's where that's coming from. The square root of negative 27 can be written as the square root of 9 times the square root of 3. The square root of 9 is 3, and because this is negative, that's an I, and we still have the square root of 3. Now, only because these two i's and the roots are the same, only because of that, now we can combine this 4 minus 3. So this would give me a 1i. You don't have to have that 1 out in front, but you sure can if you want to. So last but not least, I want you to try to do this one by yourself. Again, rewriting with I first, if that will help you. And you should have gotten negative 2 minus 2i squared root of 3. Now, last but not least, question number 6. What if we want to solve this quadratic equation? So first I have to get this equal to 0, because when we're solving an equation, we want to set this equal to 0. And now we're not going to be able to factor this because it's complex solution. We have to figure out our A, B, and C and use our quadratic formula. So opposite B plus or minus the square root of B squared minus 4AC, all divided by 2A. Now if I simplify this, this becomes 2 plus or minus the square root of negative 56 over 6. So I've simplified this root. We have 2 plus or minus, this is divisible by 4. So I can take a 2 out of that, leaving me with an I still, with the square root of 14. 14, the whole thing divided by 6. Just like up here with our quotient, we should write that with 2, our real number, and our imaginary number. So we're going to have 2 over 6 plus or minus 2i square root 14 over 6. Now, one thing you might notice that I typically write my I in front of my square root. You could, if you wanted to, write it like this. They're both the same thing. My final answer would be 1/3 plus or minus Square root of 14, I divided by 3. That's what we got for you. Have a wonderful day.